Okay, so let's copy it down, I guess. Okay, so since we're only dividing by one term, it'll be like distributive property. Every term gets divided by that one term. So you don't have to do long division or synthetic division. So
This will join. There wouldn't be any showing work because there's not much to show work.
yeah, there's nothing to show really. So 4 divided by 2 is 2. How do we do x cubed divided by x though?
X squared.
Yes, you subtract the exponents. Since that doesn't have the exponent, that's like a 1. So 3 minus 1 is 2. 3 minus 3, y3 divided by y3 is 1. It's y to the 0, which is 1, which just goes away. So then the next term, plus 18 divided by 2 is 9. X squared divided by x is x. Y4 divided by y3 is y1, is y. Minus 12 divided by 2, 6. X divided by x, done. Y5 divided by y3.
That actually worked out nice.
Okay, but 22 and 23, however, what's different about those? Okay, the divisor is 2 terms, so you cannot do just dividing the one term. You have to do long division or synthetic division. So on 23, you actually cannot do synthetic division.
It's so fake.
I was thinking synthetic division loves you. Oh, well, okay. 23, and this I think this happens on 22 as well. 23 is missing a term. You guys know what it's missing? It's missing an a cubed term. So you have to put something in there as a placeholder. So 0. And this happens on 22 as well. 22 is missing the x squared term. So you have to put a 0 in there. Okay, so anyway. You guys remember how long division works? Yeah.
For synthetic, it's for the the one that goes into the square.
In the box, yeah.
For 22, I forgot, is that negative 3 or is it?
Okay, what on 22, what do you put in the box?
3.
Positive 3.
Yo.
Right, for 23, we're dividing by a squared minus 2, but the divisor is missing an a term, so you kind of have to put a 0a in there. We've never done one quite this large.
I'm running out of room.
It's gigantic. This is going to take a while, to be honest. I'm going to go a little bit fast, though. Huh?
Okay.
Long division, yes. This big, no, probably not.
Do we have to do long division?
Maybe you want. So, you can ask me tomorrow. A5 divided by A2, this is how it starts. What's A5 divided by A2? A cubed. And then you do A cubed times this, put it down here, and subtract. A cubed times this, so it's like distributive property. So it's A5 plus 0A4 minus 2A cubed.
Mr. Jordan, do you think everything you're doing there is going to fit in this space?
You might want to start writing
I only
tiny.
have
Oh,
lines.
it's going to take a lot of lines.
Whoa. If I skip these steps.
I have like 15 lines. That's
I
kind
have
of good.
3.
You're so attractive for us.
Is that why you're at the end of your page or something?
I have an entire half a page or more.
Pig over here, like.
Bro, average kid handwriting.
What do you guys do? Kid be full of painting. I love slandering kids.
Okay. So, all right. Listen, if you move the 23 or 24, we have to subtract this bottom. We have to subtract this bottom line. So this, The pluses become minuses, girls. And the minus becomes plus. So the first term always goes away, you guys remember that? 6 minus 0 is still 6a to the 4th. 0 plus 2 is 2. Then remember you bring down the next term over, and then you start over. So what is 6a to the 4th divided by a squared? What's 6a to the 4th divided by a squared? Yeah. You just subtract the exponent. 6a squared times this, put it down here, subtract. 6a squared times a squared is 6a to the 4th. 6a squared times 0, 0a cubed. 6a squared times negative 2 is negative 12a squared. But then we subtract the bottom line, which means we're going to add the negative 12a. So that goes away. 2 minus 0 is 2a cubed. Negative 2 plus 12 is 10. Bring down the next term.
Oh no.
Start over. What's 2a cubed divided by a squared? 2a. Subtract the exponent. 2a times all that stuff is 2a cubed plus 0a squared minus 4a. But we're subtracting the bottom line, so minus minus plus. I'm going to have to zoom out. Okay, so that goes away. That's 10. That's 13. Okay, we got one more term to bring down, so that means we have to do it one more time. Plus 18. What's 10a squared divided by a squared? 10. So 10 times all that stuff over there is 10a squared, 0a minus 20. And subtract, makes it 13a plus 38. Okay, there's nothing left to bring down. That means 13a plus 38. All of that is the remainder. You guys remember how I had you write the remainders?
Oh.
You put 13a plus 38 over the divisor, which was a squared minus 2. Don't really need the 0a this time. Did you fit it in?
This is all I have so far. I don't have any of your red stuff yet.
Yeah, I brought the scroll.
No, wait, no, go back up, go back up. No, I need the answer. No,
I mean,
what?
mine so far, Braden.
You're better. You're just great.
Braden,
Get all
wait, it is? Wait, Braden, look at mine. My paper is so clean.
Oh my gosh, the front side.
Oh my god.
The front side is so
Illegible paper.
Turn it over.
Back side's pretty.
Eli, turn it over. It's like it's like somebody spilled ink on paper.
It's like the 4 plus half.
Yeah.
You're doing great, Katie.
Kid, in 3 years it'll be so good
Like
and
crazy.
if you took that home, your mom would be like, "Aw,
I could start
they helped you with math. Good job." Wait, how do they know?
Why are you so good at drawing?
Okay,
Very fun.
25 is synthetic division. So if we're dividing by x plus 2, what am I going to put in the box? Minus 2. And then the coefficients for 25. Okay, 25 again is missing a term. It goes from x fourth to x squared. So it's missing the x cubed term. So instead of putting 1, negative 2, we need to put 1, 0, negative 2. And then the negative 1, negative 10. Okay, you guys remember how this goes, right? Add down, multiply up, add down, multiply up. I'm not really too worried about this part. Alright. So what does this stuff mean though? What do these numbers mean down here? The 0 is the remainder. Negative 5 is just negative 5. This is the x term, x squared, x cubed. So this stands for x cubed minus 2x squared plus 2x minus 5.
Yay! This is average.
You're gonna do 26,
You're right.
26, no.
what?
26, you don't need to know the remainder theorem. It's just asking what's the remainder. So all you have to do is divide just like we did on 24 and 25. The remainder is the number that comes out at the end. So all you have to do is figure out the last number. Okay, 27 says use the factor theorem to determine whether x minus 1 is a factor. So how can I tell whether something is a factor or not? Like, is 4 a factor of 197? How would I know? If you divide and the remainder is 0, then yes, it is a factor. If you divide and the remainder is anything other than 0, then no, it is not a factor. So it doesn't divide evenly. So basically it's just synthetic division. Again, if I get a 0 remainder, I'm going to put yes because it is a factor. If it's not a 0 remainder, I'm going to put no. So I'm dividing by x minus 1, so I'm going to put positive 1 in the box. And all these numbers, 1, 4, negative 7, 24. Okay, add down. Putting 1 in the box kind of makes it easy. You guys notice that?
Yeah.
Because you don't, when you multiply by 1, it doesn't really do anything. Alright, the remainder is 0, so what am I going to write?
Yes.
Yes, it is a factor. That's the answer.
What's the remainder theorem?
You don't need to know a theorem, it's just, they're asking what the remainder
Did you
is.
change
Oh.
it 1 through 28?
Oh yeah.
Let's get that way.
Yeah, it was 27 yesterday. Okay, speaking of 28, how do we use the rational root theorem to find all possible rational roots? What was that about?
Do you put like 6 or?
Factors of 6 over factors of 2. You guys
Oh yeah.
remember? Oh,
Oh,
yeah. And that's kind of what we're going to have to use to solve, help us solve, what the heck?
Of course, that's my favorite.
You want to see kids
We're going to need that to help us solve 35 and 36.
The most fun thing to pull.
I mean, think about it. Is there any way you can improve your handwriting by chance?
No.
Please.
Not for this one.
Please.
Okay,
Do they not teach you how to
shh. All right. On this one, what should we do first, you think, to solve this? Move it, yeah, move it all to one side. So it's in standard form. So I'm going to subtract the 7x and the 15. Okay, does that factor? No. We can't like take an x out or anything, and we don't really have tricks for x cubed factoring normally. Some, occasionally there is, but not usually. So anyway, this does not factor. So if it doesn't factor, how can I find an answer? Rational root theorem. So what are the possible rational roots? What are possible answers for this equation? Factors of 15 over factors of 1. Factors of 15. Factors of 1. So it's 1 over 1, 3 over 1, 5 over 1, 15 over 1, which is just 1, 3, 5, and 15. They could, yeah, technically factors of 15 could be negative 3 times 5 or negative 5 times 3. So these could all be positive or negative. I don't know if you guys remember, how many answers should this normally have? This
3.
normally 3. Sometimes there's a double root, a double answer, but generally it should have 3. But really we only have to find 1 before we can kind of use a trick to find the last 2. So how do I find one answer though?
You plug it in.
Plug it in. If I plug in 1, this would be 1 plus 1 minus 7. Does that equal 0? No. If I plug in negative 1, whoops, not efficient. If I plug in negative 1, I get negative 1 plus 1 plus 7 minus 15. Does that work? Yeah, that look like it does. 3, I kind of forgot what the answer was, to be honest. Does 3 work? This would make minus 36, and this would make plus 36. So, yeah, 3 does work. So 3 is an answer, so we got one of them. And basically, we divide the answer out to find the last 2 answers. So I'm going to use synthetic. It's not, we're really dividing by x minus 3 because if 3 is the answer, so don't switch the sign is what I'm saying. If 3 is an answer, just keep 3 in the box. You only switch the negative thing if it's normal division. Okay, so I'm going to do my synthetic thing. Okay. By the way, this should come out as 0 if it really works, and it does. So what does this 145 mean? Okay, and I want it to equal 0. So this is now a quadratic. It's an x squared, so I can just use my, what are the 2 ways to solve quadratics? Factoring quadratic formula. Does this factor? Do 2 things multiply into 5 that add up to 4? Okay, it's kind of a trick question. Like 5 and 1 multiply into 5, do they add up to 4? 5 and negative 1 add up to 4, but do they multiply to positive 5? No. It's kind of a trick. It doesn't actually factor. So if it doesn't factor, what do we have to do? Quadratic formula.
What? Why am I in this class?
Calm down.
Really? You hate the quadratic that much?
It kind of stinky.
Negative b
You know it's more stinky.
plus or minus square root of b squared minus 4ac over 2a. See, it's not that bad.
It's average.
Red case,
But you make us write it out.
You don't.
How can you do it without writing it out?
Your brain.
Incorrect.
I mean,
I write it down and then I erase it.
Stop erasing it.
It's cluttery. For real. That's like, yeah.
I mean, come on, guys.
These
Come on,
are like
It's
Skylar's
supposed-
tutorials. You have to navigate for her number
Like,
5.
really interesting.
It's like across the entire page and number 4 is over here.
You have to learn to live with the mess.
Those are packs
Look
right
at
now.
mine.
Why are
Mine's
you writing in
being
a notebook?
organized. I just hate having it there.
Why are you writing it
It's
down
not
in a notebook?
paper.
No.
It's not on a piece of paper, it's on like a notebook.
You can tear the book. I don't know why you're
That's
For real,
stupid.
where did he come from?
Okay.
Like,
Anyways,
Why is this not working?
Average English kids.
this is going to come out as a negative 4. Hush. This comes out as negative 4 in the square root, which means what?
Oh yeah. It's I.
It's an imaginary. Square root of 4 is 2, but if there's square root of negative 4 is 2i. It's imaginary. It doesn't exist. So, and do you guys also remember that you have to split it up when you have an imaginary? Your calculators do this automatically, so if you have a nice calculator. But negative 4 over 2 is negative 2. 2i divided by 2 is just I. Okay, so there's 2 imaginary, 2 complex answers, plus, well, as well as, remember 3 was an answer from way back beginning. So that's the 3 answers right there. 3, negative 2 plus I, negative 2 minus I. Yes, it is a lot of work. Wait till we do 36.
Are we doing 6 together?
No, but I'll help you start. So I'll do half.
So yours like giving us a fair warning. 36 is horrible.
Well,
So different.
it's not horrible, it's just large. What is different about 36?
It has a 4.
I'm still doing 23.
Just because you were doing something else when I was doing 23.
I was doing 23 at the same time you were doing 23.
I was good.
Well, sorry, I went kind of fast.
I'm a new person.
Please help me.
Okay, so what are possible answers for this? Possible rational answers? Factors of 6, factors of 1.
I don't like this. Literally, no one does.
We're not doing it for your entertainment. If you enjoy yourself, that's just a happy accident. Okay, so we got 1 over 1, 2 over 1, 3 over 1, 6 over 1.
Is the remainder really good on this one?
Remainder.
Yeah.
We're not dividing.
What would you do like the...
Every time I lean forward to pick
Yeah,
up,
I can't.
Actually,
I can't prevent it.
If you get a remainder when you do the synthetic, that means it's not an answer.
Oh.
3 was an answer because it came out as 0.
Oh.
Okay, but I usually check up here to see if it works. Like if we plug in 1, is this gonna work? 1 plus 3.
Well,
Okay, looks like no, that does not equal 0. If I plug in -1 to the 4th is 1.
It doesn't work.
Okay. That looks like that doesn't work either. Wait, did I remember it wrong? Because I thought 1 was an answer.
Wait, I think
1 3x
Are
cubed.
you sure that's not right? I think that's right.
It is?
Yeah.
Oh yeah, yeah.
Negative 9.
I didn't see this 19.
Oh, I did it first.
That adds up to 20 and minus 20. Yeah, it does equal 0. Okay, -1 works, so I'm gonna divide it out. Okay, what makes this one more challenging is it's an x to the 4th. So that means it should have 4 answers normally. So you have to take 2 answers out before you can get it down to an x squared. So we have to kind of do this trick twice. So -1's gonna work.
There's so many parts to this.
Yes,
So huge.
this is true. Okay, -1 does work. Okay, but my leftovers down here is like 1x cubed plus 2x squared. It's still a not factorable. So I have to find something else that works. Okay. I don't want to hear you whining. Keep it to yourself. So 1 and -1 have already been checked. 2 and -2. Did you get 3 to work?
I don't know, I just guessed.
That was a good guess.
I do that.
When I was yelling in your ear when you were saying
Oh,
it was -1, I was like, 3.
Sorry.
There's 4 answers.
I was yelling in your ear. Yours does not listen to
Okay,
me.
anyways, 2 and -2 would not work if you tried it. 3 does work because... Okay, notice though I'm taking 3 out of the leftover stuff, not the original. Whoops, I did something wrong.
So I went all the way down to 3 because I did it.
Oh, 15. Okay, so I've got 2 answers that work. And I've got the leftovers right here. So how do I find the last 2 answers? Okay, does this factor? No. Does anything multiply into 2 that adds up to 5? No. So you have to use quadratic formula. So you got these 2 answers plus whatever comes out of the quadratic formula. Okay, that's where I'm gonna get off the bus.
Is 37 as long?
I'll probably make, no, the rest of them are kind of easy. I'll probably make 35 a question like 35 on the test. If I put 36 on there, it'll probably be like a bonus.
Aren't we skipping to 39?
Okay, we're jumping to 39, yes, not 37.
Is this one gonna be a long one, or do I need to start off with a page?
No, the rest of them are kind of short. I mean, 41 has like 5 questions, but they're all short answers. 39, so this is talking about what the graphs look like. You guys remember the patterns from, was this Monday we talked about this? I can't remember. No, we did a worksheet on Monday, didn't we? It was last Friday. You guys probably forgot last Friday. So if the graph starts off with like a 2x cubed, we immediately, if the function is like 2x cubed, we should immediately know what the picture is going to look like. You guys know?
It's gonna see.
Okay, an odd degree, an odd power, makes it go like down to up or up to down. If it's a positive, it's going to go in a positive direction, so it's down to up. If it were like a negative on the leading coefficient, it does the opposite, goes in a negative direction. Okay, what if it is a 4th degree or an even degree? It goes up to up. If it's a positive, it goes up to up. If it's a negative, whatever, it goes down to down. Okay, those are kind of the patterns you need to know. So on 39, the first question is, what's the degree of the polynomial? What's the degree of the polynomial on 39? 5. It's the largest power. What's the leading coefficient? Negative 2. So what shape should this make if it's an odd degree and a negative coefficient? Up to down. It's kind of like the squiggle, but it's got another curve and a couple curves in it. So anyway, it looks like that. So the end behavior is up down. I was thinking that too, but I don't know what your dad looks like.
Looks like a toe.
I see him walking to work.
I was like a scour set. I just actually mean it.
You guys are all just
Well,
blurring my
no, he has to park his car so far away. And then he has to walk.
Kid, I'm sorry, your handwriting is horrible. I'm sorry.
You know what's crazy about my dad? She said his ugly looks like Mr. Bean.
Kid, try some
This is Stanley went off on her.
Stop having your hand. At least it's the up and down.
Okay, guys, 41. Given the graph of the thing on the right, what are the zeros of the function? So what are zeros? What do they mean? It's x-intercepts. Because that tells you the x values that make the function equal 0. So what are the x-intercepts on 41?
-2, 0, -4,
Okay, you could say -2, 0, but they just put -2. So -2, what else? -4. Where else? 1 and 3. Yes, it's not trying to trick you here. That's where it's crossing the x-axis. That means if we had the original function, if we plug those 4 in, they should all make the function equal 0. The 0 should split out. Okay, anyways. B, what is the y-intercept? No, not the range. What is the y-intercept? 2. On this one, they were more specific. They did put 0, 2. Although if you put 2, if this wasn't an odd and you put 2, I would still accept it. C, what is the domain? Domain is the x values, which means how far left and right does it go?
You're right.
All real number.
It's everywhere. It goes forever both directions, so that means it's everything, all real numbers. The range is the y values. That's up and down.
X is greater, y is greater than -3.
Yeah, the lowest y value is -3 if you look at that valley on the right. It goes down to -3. What's the highest y value? There isn't one. It goes forever up. So it's all the y values that are greater than or equal to -3.
What's an extreme? I never improved.
I'm just
Okay,
helping you.
D, I've never mentioned this because it didn't come up in the homework, but it's actually easy. Extrema is just like a fancy way of saying, well, it sounds like extreme, right? It means, sometimes they're called a local max and local min. It means like where's the bottom of the valleys and the top of the hills. So that valley on the left, kind of like the vertex a little bit. So what's the bottom of the valley on the left?
-3, -1.
-3, -1. They're not usually that important. I guess they point them out because if this was like modeling some real life situation, the hills and the valleys would probably mean something. Okay, what's the top of the hill in the middle?
2, 0.
Well, 0, 2.
Oh yeah, sorry. I'm stupid.
I always.
And what's the bottom of the valley on the right?
2, -3.
2, -3.
0, 2.
Ugly.
How would you do that?
It's not very
Bro.
I
think you did.
I know
No, I did not. You're such a liar. You said
Literally,
I was
it's
right.
not
No,
right.
there's no way. Wait, hold on. Did you draw that? Why did you draw that?
You guys are yelling at each other. Comments like that.
Oh my god.
You're
Oh my god.
You're rude. I get so scared. Oh,
Sorry.
Anya, they were about to get in a fist fight. And you just sitting there. giggling.
Why would you write that?
Okay, the last question was, is the degree gonna have to be even or odd?
Even.
Yeah,
No.
if it's up, that has to be an even degree. All right,
Go. Can you go back to 23?
Oh my god.
yes, I can.
Why do you go back to 23? It's not even that much. It's not left.
Well, 23 is way good.
It's not that much.
Dude.
I just don't have left.
Why do you need to write all that down?
Don't worry.